Hello and welcome to our YouTube channel Chemistry with Tanvi. We started the halogen derivative chapter. In previous 9 lectures we studied up to the reaction with the active metals. Now today's topic is reaction of haloarenes. So what is mean by haloarenes? If halogen atom is attached to the any benzene ring is known as haloarenes. They are represented as AR, that means aromatic ring, and X. So they are haloarenes. Reaction of haloarenes with metals. First one is with alkyl halide. Likewise, alkyl halide with sodium in presence of dry ether. We studied this is our Woods reaction. Same in aryl halides also Woods reactions are there. Here also same sodium metal is used in presence of dry ether. So in this reaction, the reaction of aryl halide with our alkyl halide in presence of sodium and dry ether gives rise to aromatic compounds. This is aromatic compound is known as Woods fitting reaction. This is a extension of Woods reaction and was carried out by fitting. This reaction allows alkylation of aryl halides. That means जब भी हमें कोई भी अल्किल सेम R ग्रुप अगर एरोमेटिक रिंग को चाहिए तो ए रिएक्शन हम यूज करते. फॉर दैट वी यूज फर्स्ट वन halide of aromatic compound and halide of aliphatic, that is RX compound. Okay, in presence of sodium and dry ether we get the compound which is aromatic one and twice of NaBr is removed at the side reaction. In case of only if we taking 2 moles of or the aryl halide only, not alkyl halide, then it reacts with the sodium in presence of dry ether. Then the formation of or the fitting takes place between the same type of aryl halide, that is chloro. Here halide is a chlorine and aryl ring is our benzene ring. So chlorobenzene, if twice of this chlorobenzene reacts with the twice of Na molecule in presence of dry ether, then we get the biphenyl product. That means this दो बेंजीन रिंग जो है वो सिंगल बॉन्ड से कनेक्ट होती है और हमें साइड प्रोडक्ट ट्वाइस ऑफ NaCl भी मिलता है. सो दिस इज़ द इम्पॉर्टेंट रिएक्शन. और इन एग्जामिनेशन आपको आता है हाउ विल यू प्रिपेयर बाइफेनिल फ्रॉम aromatic halide, then your answer should be like this. For this reaction we first take the 2 aromatic alkyl halide compound which is our chlorobenzene, react with the same sodium in presence of dry ether gives rise to biphenyl. Phenyl means C6H5. We know that benzene means C6H6. It is our benzene. C6H5 is our phenyl and C7H7 is our benzyl. Okay, then next is here for the next reaction, nucleophilic substitution of haloarenes. This is our next point, that is nucleophilic substitution SN of haloarenes. We already seen the substitution reactions in alkyl halides, that is SN1 and SN2. For the alkyl aromatic halides also there are substitution nucleophilic reactions. For this we know about the knowledge of resonance, where what is mean by the resonance. First one is concept. So this resonance means what? First of all, resonance is only happen with the aromatic unsaturated, that is conjugated system. Conjugated means alternate single and double bond. carbon-carbon single and carbon-carbon double bonds are alternatively present, that means conjugated system. Then this resonance means delocalization of pi bond electrons. Pi bond electrons means double bond. Pi bond electrons over a aromatic system or a system is known as resonance. Resonance always shown by the double-headed arrow. They are generally conversion of from first to fifth structures are there. In all the structures there is delocalization of pi bond electrons. Single and double bonds are alternatively changed. If the first structure there is position of 4, 5, 6 carbon up to the last structure, the position of single and double bond gets changed. So this is our fifth. 5 structures are resonating structures. All resonating structures show in a single form called as a resonance hybrid, having the more energy than the each resonating structure, in which what happen, this single and double bond position changes by showing the dotted circle, making by the dotted circle. These are the some points of resonance. Resonance are always happening in a aromatic system, unsaturated system, as well as in a conjugated system. Resonance means delocalization of pi bond electrons over a system. Resonance structures are shown by the double-headed arrow and their changes. Generally 5 resonance structures are there present in an aromatic system. For an aromatic system there are 5 resonating forms or structures, and they are shown like this. Every movement or change of single and double bond, place or movement or delocalization shown by the dotted circle. Okay, if we see, let us look one example here. This resonating structure or effect is shown by R later. They are of two types, minus R and plus R. This plus R effect means electron donating effect. Electron donating effect. So let us see the first example, that is OH. This OH means बेंजीन रिंग को अगर OH रहता है तो उस कंपाउंड को हम क्या कहते हैं, फिनॉल. देन व्हाट हैपन, प्लस आर इफेक्ट, दैट मीन्स दिस OH ग्रुप डोनेट करता है इलेक्ट्रॉन बेंजीन रिंग को. हियर दिस डबल बॉन्ड गोज, lone pair goes here and this double bond goes at the corner. Then what happen in next structure, this is remains unchanged, this forms, this is remain unchanged, positive charge on it. Here the negative bond is there and this is the positive bond or new bond is formed. Okay, then in next structure what happens, this bond goes inside the ring and this goes at the corner. Then in next structure, this is our bond form, this is unchanged, this is coming bond, this is remains unchanged. Then next structure, this double bond goes inside the ring, this inside bond is at the corner of the ring. Then the formation of this, here double bond at the corner, here the bonds are formed and this is unchanged. Then in last lecture, this bond goes inside the structure and this bond goes as the lone pair. Then the formation of this structure like this. Okay, this is our final structure. These are number 1, 2, 3, 4 and 5 structures. Generally in aromatic system there are 5 resonating structure. Here this is the electron donating plus R effect. ओके। दिस OH ग्रुप बेंजीन को अपने खुद के इलेक्ट्रॉन देता है। वो इलेक्ट्रॉन्स जो होते हैं आइदर लोन पेयर के होते हैं, लोन पेयर को भी हम पाई इलेक्ट्रॉन्स बोल सकते हैं। तो इलेक्ट्रॉन ओवर सिस्टम लोकलाइज्ड होते हैं, डी लोकलाइज्ड, दैट मीन्स मूवमेंट चलती रहती है। तो फाइनली हमें ओरिजिनल स्ट्रक्चर मिलता है। लेकिन उसमें क्या होता है, मैंने क्या बताया, जो डबल बॉन्ड की पोजीशन है फर्स्ट स्ट्रक्चर में, लास्ट स्ट्रक्चर में वहाँ सिंगल बॉन्ड रहेगा। ओके, हियर सिंगल बॉन्ड, हियर single bond is there. In this structure there is presence of double bond and so on. There is alternating position of single and double bond. So these are the some example, that is amino group, OR group, alkoxy, CO group, NO2 group, cyanide group, then vinyl group, SH thiol group, alkyl group attached to the double bond, that is CH to CH, and PR3, that is phosphonium group. These are the some example of plus R effect. Then see the minus R effect. Minus R effect, that means electron withdrawing effect. Electron withdrawing effect. इसमें क्या होता है, जो हमारा फर्स्ट स्ट्रक्चर रहता है, कोई भी एग्जांपल ले सकते हैं हम. हियर वी टेकिंग एज अ NO2 group. Okay, here our benzene nitro benzene structure is there. Then what happen, first of all here, then this goes here and this is okay. In for the nitrobenzene, what happen, this is electron withdrawing group. Nitro group is very reactive, very much reactive, so they having tendency to here O minus. This nitrogen group having tendency to withdraw the electron from the benzene ring. So this is our first structure. Then what happened, these bonds remains unchanged. This is original bond, this is newly formed double bond, this is nitrogen having O minus and O minus. Here positive sign is there because of electron deficient carbon atom is formed. Then to this balancing plus charge, this bond goes here and the next structure is formed like this. Here double bond is there, here double bond, here the remaining groups showing unchanged. Here positive charge at the corner of para position with respect to NO2 group. Then what happen, to balance by this goes here and the formation of this structure, like here positive center is electron deficient center is created, O minus. Then what happen, this bond goes here and this is balance. So in last structure we get the original structure, only difference in interchange in position of the carbon double bond, carbon carbon single bond. This is our final 1 2 3 4 5th structure. Okay, this is also shown by the putting double headed arrow between the all structures. The resonance hybrid, that is the final structure, which shows the all the changes in a compound, is shown like this. Here double bond is formed, here double bond is also formed, here the double bond and single bond is forms. This is also goes breaking and making of bond show in a same structure of resonating form is called as resonance hybrid. Resonance hybrid structure. This all seen in 11th standard. Then for this, the nucleophilic substitution reaction. First one is so this is about the knowledge about the resonating form. So nucleophilic substitution SN of haloarenes. First is the from para-nitrochlorobenzene to para-nitrophenol. This is our the first reaction, in which what happen, we need the removal of this chlorine. this removal of chlorine takes place in presence of this chlorine is a which group? Electron donating or electron positive. These are the series containing the minus R effect. Here chlorine is a electron donating or electron withdrawing group is there. This is electron donating. All halogens are electron donating, that is plus R effect. So what happened after resonating structure? This chlorine is removed and in place of chlorine there is OH minus group is attached, replacement of chlorine. So the formation of this compound takes place, that is aromatic halide is cancelled out with the by putting the OH group in place of halide. Then next is this is the structure of 2,4-dinitrochlorobenzene. Then the formation of 2,4-nitrophenol. This chlorine is removed. Again putting the aqueous sodium carbonate and 403 Kelvin and hydrolysis, that is in presence of water or H3O plus. Then the formation of this removal of Cl by OH takes place and we get our product. These examples are very much important for the point of examination. Then next is 2,4-trichlorobenzene. This is on reaction with boiled or warm with the water. Then the formation of this removal of chlorine takes place and to this chlorine OH group is attached. That means we get 2,4,6-trinitrophenol compound. Okay. Then next is up to this much the reactions of haloarenes with the help of nucleophilic substitution reaction. Then next is reactions of haloarenes C, that is electrophilic substitution reaction. First one is in halogenation. Okay, it is a very simple reaction. It is carried out by reacting haloarenes in presence of ferric salt as a Lewis acid catalyst. This Lewis acid catalyst FeCl3, then AlCl3, FeCl3 or AlCl3 acts as a Lewis acids catalyst. First, if we taking chlorobenzene, addition of chlorine to it in presence of anhydrous FeCl3, then we get two products, ortho and para. This is 1,4-dichlorobenzene obtained as a major product, and this is 1,2-dichlorobenzene. This chlorine is not replaceable because this is our substitution reaction. One of the hydrogen of this chlorobenzene either from ortho side or either from para side is replaced by putting the chlorine. Then we get the product this, and removal of HCl takes place. But in case these two products obtained, and here the major product is always para product or 1,4 product. The next is nitration of chlorobenzene. For nitration we always use the reagent. First of all, reagent is HNO3 in presence of concentrated H2SO4. The mixture of concentrated HNO3 and H2SO4 gives rise to our electrophile, that is NO2 plus. So any reaction of nitration, here the concentrated mixture of concentrated HNO3 and H2SO4 is added. So in this chlorobenzene when treated with the HNO3, we get the two product, again 1,chloro,4-nitrobenzene and 1,chloro,2-nitrobenzene. Here also two products are obtained, that is ortho and para. Okay, these obtain as a same proportion. In next reaction, that is sulfonation. Sulfonation means what happened, which group added to the ring, that is sulfonic acid group SO3H. In Halogenation, halogen is attached and in presence of AlCl3 or FeCl3 as a Lewis acid. For nitration, what happens? Which type of material is used? Reagent is used concentrated HNO3 and concentrated H2SO4. For sulfonation, SO3H group is attached or replaced the hydrogen of aromatic ring. This is present only in H2SO4 in the form of fuming. Or fumes of H2SO4 used for the SO3H, a replacement of hydrogen by SO3H on an aromatic system. Then next is Friedel-Crafts alkylation. Any alkyl group is added to the aromatic system in presence of again anhydrous AlCl3, and if we add the acyl group COR, then again use anhydrous AlCl3 as a reagent. These are the 5 simple methods electrophilic substitution reaction for benzene for aromatic halides. Okay, here the third reaction is, that is the sulfonation. That means one of the hydrogen from either ortho or para position replaced by the SO3 group is known as sulfonation. Here also one chloro, this is biggest group than the chlorine, so it is a parent. 1 chloro benzene sulfonic acid, 4 chlorobenzene sulfonic acid. These two products are obtained. Then next is Friedel-Crafts reaction. I already told that for Friedel-Crafts reaction there are two types, alkylation and acylation. If we want to add alkyl group on the benzene ring, then we use the anhydrous AlCl3 and alkyl halide to the aromatic halide, that is chlorobenzene. Then the formation of again ortho and para products takes place, that is 1 chlorotoluene and 4 chlorotoluene. This chlorine, towards this chlorine, here the CH3 is come or at the position of 4th. So these two products are formed. Then next, if we take this acyl chloride, that is CH3COCl, this is our acyl chloride in presence of anhydrous AlCl3. Again we get ortho and para derivatives of acyl chloride. The name of this compound is 1-chloroacetophenone, 4-chloroacetophenone. Why it is called as acetophenone? Because this R, CO and this is R. RCOR is our ketone. So ketone is a parent in this. The parent is phenone, that is benzene ring is phenolic ring. So phenone is a parent. Then to this aceto group is attached, CH3CO is your aceto group. So aceto and 1 is a chloro position. Here 4-chloroacetophenone. These two structures are formed. Okay. In this way, our all reactions are over. In next lecture, we study the uses and environmental effects of some polyhalogen compounds. Thank you for watching. If you enjoyed this video and found it helpful, please give it thumbs up, leave a comment and subscribe too. Don't forget to hit the bell icon to stay updated to our latest videos. See you next time. Bye bye.